Good afternoon. My name is Jacob Delgado. I'm here to speak to you about my research in data science and robotics with emphasis in drone technology. As drones become more and more widespread, their features and specifications are constantly evolving. This is also true with the cameras that are installed into the drones themselves. They're constantly improving the resolution, frames per second, and many other features. What my research primarily focuses on is ensuring that the camera's gatherings and the camera's data gatherings on optical flow are in correlation with the overall movement of the drone itself. To make sure that the camera itself is operating correctly, a camera rig was designed using 3D modeling software, specifically SolidWorks and Inventor. And the main hurdle now to overcome is ensuring that the rig itself is collapsible so that transportation can be easy for us when we are conducting testing. Our objective for this goal is that in making sure that the camera rig itself is collapsible, we do not compromise the data readings that we would get from the rig itself or from the camera. To ensure that this is possible, how we're doing it is we are implementing a sturdy outer frame that would be held together by bolts and screws, but then at the frame in the center where the camera itself will be operating and moving and conducting optical flow analysis, there will be pins along the side that will be easily removable to ensure that that frame itself can be removed. And for the base, pins will also be inserted so that when they're removed, the legs will move upward, creating a flat surface, and that will help us to transport it easily. And our goal with that is that since the overarching frame on everything is still rigid, that this will allow for there to not be a larger margin of error when conducting our test and analysis. Once we can ensure that the camera itself is moving in correlation with the location in which we are moving the camera, then we can attach it to the drone and do further test and readings to see if there are any other factors that may be causing errors in the drone itself. At that point, we'll be adjusting the features and specifications on the drone, and then once both of them are to the level that we need them to be so that the optical flow tracking from the camera and the movement of the drone are in sync, we can move on further to ensure that other specifications and improvements can be made that we would like on the drone. This is what the overarching research will be dedicated to for the 4 month span in which we are allotted to conduct our research. And then in the end, we hope to have a more efficient and properly functioning drone as a whole. Thank you for taking the time to listen to my little breakdown about the research that we'll be conducting throughout these next 4 months. Hopefully it was informative, and have a nice day.